some idea about your sequential circuits. So when we talk about sequential circuits, these two devices or components are very important. One is latch and another is resistor. So a latch is level sensitive. A resistor on the other hand is edge triggered. So there are many different naming conventions. Some books call edge triggered elements as flip flops and so on. So it does not matter. But the thing that matters is you should understand that a latch is level sensitive. That means it depends upon data. When data is ready, things get processed, while resistor does not depend upon data. It depends upon when clock is ready, whatever may be the data, it will be processed. So latch stores data when clock is low and resistor stores data when clock rises and so on. So these are the two depictions of your latch and your flip-flop. So here you can see that when clock changes, whatever the data is being processed. So this clock is changing, so D is equal to 1, it is now this. Now again when clock is high, your data is high and your output remains high and so on. Whatever may be data will be immediately reflected as per the clock. On the contrary, in this edge triggered thing, so edge is there, whatever data is being reflected, edge is there, whatever data is reflected, so it does not die here. It is waiting for the next clock edge to come. But here, this clock is rising here, but in the meanwhile, the clock is high for this duration. If some change in data is there, it will be immediately reflected at the output. So that is the difference between your latch and resistor or latch and flip-flop and level triggered and edge triggered thing. So again, two kinds of latches are there, positive latch and negative latch. So this can be depicted in this particular diagram. So this is your clock, this is your input, and this is your output. So when clock comes, whatever your data is, it will be immediately reflected. So when clock is low, any change in data does not have any effect. So whatever thing is stored, it remains as it is. Again clock is high, so again clock is high for this period, so whatever data will be reflected at the output. So in the nutshell, we can say that your output follows input when clock is available. If clock is not available, the things are opposite. So this is the case for positive latch. And when negative latch is there, when clock is positive, you change input does not affect your output, remain as it is. And when clock is low, whatever your input is, output will be like this. Things go like this for this particular thing. So this is a positive latch, this is negative latch. Now the basic component which we already studied in digital electronics subject during graduation, undergraduation course, that is SR latch circuit. So here you can find out that you are having input S and R, and contrary you are having output Q and QR. So set is basically being used for set and R is being used for reset. So this is NOR based latch. So its truth table goes like this. So when both the inputs are 0, then what happens? Your output is being held. Whatever is the output in the previous state will be held by your device. Now when your set becomes 1, what happens? Your output changes to 1. If it is 1, it will be 1. If it is 0, then it becomes 1. Similarly, when your R is 1, your output changes to 0. Or we can say when S is equal to 1, your device is set, and when R is equal to 1, your device is getting to reset. This particular transition is being prohibited. When both the inputs are 1, this is not being allowed because it does not allow your things to settle. Both the outputs are 0, and as assumed, two outputs are complementary to each other, but this is not being justified, so this is not being allowed in this particular thing. Now, this is your SR latch circuit, and how it performs, you can see that when S is 1 and R is 0, what happens? When S is 1, R is 0, then M1 and M2 are on, while M3 and M4 are off. M3 and M4 are off. So when they are off, what happens? Your output remains high, as discussed. Similarly, when your R is equal to 1, then what happens? M1 and M2 are off, M3 and M4 are on. So your output becomes 0. Output becomes 0. So this becomes, when these two transistors are on, gradually this becomes 0. Sorry, this becomes 0. And similarly, when M1 and M2 are off, so what happens? Your Q will be high. And so on. So when both are high, S and this high, so what happens? Both goes to 0 level. So that is not desirable. So we avoid that particular configuration. So this is the example of typical SR latch circuit. Now, clock, latch and flip-flop circuits. The circuit which we have discussed previously is asynchronous in nature. So synchronization can be introduced through clock, which the outputs will respond to the input level only during the active period of a clock pulse. So here you can see when clock is 0, as you can see the clock is 0, SR have no influence on Q and Q. Why? Because this is a AND gate. So for things to get set, your clock should be 1. While again this particular transition is being prohibited. So now we know the basic thing. Now we will discuss how this can be implemented using MOS circuits. So here you can find out this is a clock, this is a clock, again this is a clock, this is set button, this is reset button. So things go like this. So you can see when clock is 0, so things will not change. But when S is equal to 1 and R is equal to 0 and clock is 1, what happens? Now your device is ready for transition. So when S is equal to 1 and clock is 1, what happens? This will be ground. This is 0 and clock is 1, what will happen? This will become 1. This becomes 1. And similarly, when this is 1, what happens? This becomes 0 and this becomes 1. And so on. This is OR and invert based implementation of clocked NAND based SR latch. So I hope you get a fair idea how to devise or design your SR latch using MOS circuits. So many combinations are there. Although this is a basic course, so we will not be able to discuss in this particular course the designing things in more detail. But if you require, we can get into the detail once your syllabus is completed. So thank you very much. I hope you enjoy the learning, and if you have any doubt, you can email me, you can call me. Thank you.